Hello, I'm Dr. Zia Tahir. This video tutorial is solution to problem 4 by 36 from Engineering Mechanics Statics 9th edition by J.L. Meriam, L.G. Craig and Jen Bolt. Statement of the problem is determine the forces in member BC and FG of the loaded symmetrical truss. So that is BC and then it is FG. So this is a symmetrical truss in geometry, but the loading is unsymmetrical or that is not symmetrical. And need to find member forces BC and FG. So now sport A and sport H. So they are simple sports or pin sports. So there are two reactions at each sport. So total there are four unknown reactions. So for those four unknown reactions, it is not possible to solve this truss using conditions of equilibrium, as there are only three conditions of equilibrium. So overall, this truss is statically indeterminate. So it is not possible to solve it using conditions of static equilibrium. Then, so method of joint is not possible for this truss because the method of joint that uses only three conditions of equilibrium. To show that this calculation can be accomplished by using one section and two equations. So now when the other option is method of section, because in the question it says that method of section. So using two equations, one section and two equations. So then for BC and FG, it is possible to draw a section. The first possibility, which is straight away, that is section passing through here. So the target members are BC and FG. So passing a cut there and dividing uh, truss into two sections. So the upper part of that has two forces only. So it is possible to solve that statically indeterminate truss using method of section. But there is a problem because whenever we have to take a cut, so at that cut there must be three or less than three unknown member forces because equations available to analyze that upper section. So there are three. It's not possible to find those four unknown member forces B, C, B, J, G, J, and F, G using method of section. So then passing a section from here is not appropriate. So then because it says that two equation and each of which contain only one of two unknowns. So then uh, it's mean that only two equation need to be used and then each equation contain only one unknown. So, and then this is not possible. So the other possibility is I can cut it from here. Now cutting it from here again, at the cut, there are four unknowns. But those four unknowns can easily be eliminated by taking moment about point C. Okay, so if I'm going to take moment about point C, so what is going to happen? That BC, CJ, and FJ, three unknowns, are going to pass through that C. So it is possible to find that unknown FG by taking moment about point C. And similarly, if I take moment about point F, so then FG, FJ, and CJ are all passing through point F. So then it is possible to find BC using a single equation. So whenever there are problems or stresses like that, which are statically indeterminate and method of joint is not possible, so then using this type of unusual cut, it is possible to solve them uh, using conditions of static equilibrium. And say, are the results affected by the statical indeterminacy of the support at the base? So because we are not going to include that lower part of that, so then statically indeterminacy is not relevant here because we are going to use the upper part of. Now I'm going to draw free body diagram of the upper part and show all external loads. So there are two external loads and then unknown cut member forces assuming tension. So there are four unknown cut member forces. So all they I'm going to assume in tension. So here is a free body diagram. So for the free body diagram, so at C and D I have shown loads, and then BC, CJ, FJ and FG I then all assumed in tension. The next one is I need to apply conditions of equilibrium to the cut part to find unknown. And here I will use a point C or point F to eliminate most of the forces. So now, if I take moment about point C, so what is going on? If I'm taking moment about point, so B, C, C, J, and F, J are going to pass through C, and then the only unknown is Fg. So by taking moment about point C, that three forces are eliminated, then I can find Fg. So now taking moment about point C, sigma mc equal to 0. So then there is a 1200 load and it is acting in DE and its perpendicular distance from point C is CD, which is 2 meter, and it is going to produce moment in clockwise direction, so which is 1200 times by 2. The other one is FG. So that is the line of action of FG, and the perpendicular distance of FG from uh, point C is 4 meter, and it is going to produce moment in clockwise direction. So then moments I have 1200 times 2 negative, because I'm going to assume that clockwise moment as negative, and the other one is Fg times by 4 equal to 0. So now that is a simple equation and it can be solved. So it can be 4G equal to minus 2400 and Fg is equal to minus 2400 over 4. So that is going to be minus 600. So now one unknown Fg is now calculated. Next, I'm going to take moment about point F. So CG, FJ and FG, they are going to pass through F. So moment due to them is 0. 800 is also passing through F, so its moment is 0, and that is a BC. So the perpendicular distance from the line of action BC to CF is 2, and it is going to produce moment in BC, and that is going to produce moment in anti-clockwise direction. Then 1200, so 1200, the line of action of 1200 is along DE, so it is actually going to act here, and it's a perpendicular distance from the line of action of 1200, which is DE, to F, it is 2, and it is going to produce moment in clockwise direction. So then taking clockwise moment as negative and anti-clockwise moment as positive, so it's going to be 1200 times by 2 negative plus BC into 4 is equal to 0. So that is a simple equation. It can be solved to get BC. So 4BC is equal to 2400 and BC comes as plus 600. So now FG and BC both are calculated. So once member forces are calculated, then use interpretation of sign of unknown member forces. A positive value indicate tension and a negative value indicate compression. So Fg is negative. So then Fg is going to be 600, and then BC is, so that is 600 Newton in compression, and then BC is 600 Newton in tension. So now both of those forces are calculated. The answers at the back of the book are BC as 600 Newton tension and Fg as 600 Newton compression. So that is a complete solution of this problem 4 by 36. Thank you very much for watching.